Hi, I'm Dr. Karen Agar, and this video is part 2 of the demonstration of concepts from Chapter 10, Classes Continue. In the last video, we created a bankaccount.java class. You can see the UML diagram for this class here. In this video, what we're going to do is we are going to be storing a collection of bank accounts in a class named bank. We're actually going to do this twice. We're going to implement bank1.java and then later bank2.java. The only difference between these two classes will be the type that we're using to store a collection of bank accounts. We'll first observe this bank1.java. You can see it has a single attribute, which is going to be named accounts, and it is going to store a collection of bank accounts using an array list. It will then have a method named getAccounts that returns that collection of array lists. We're going to see how to interact with an accessor returning a collection of objects. Then it's going to have an addAccount method that allows the bank to create a new bank account, add that to its array list, and then a removeAccount method. Bank2 is going to be exactly the same, except Bank2 is going to use a hash map to store these bank account objects. This hash map is going to map each bank account object to an integer, which is its account num. Again, going back, each bank account has a unique account num that we created and implemented in the last video, so it's going to map the account number to the bank account. The methods are going to be the same, except they are going to work with the hash map collection here. By going through these examples using both an array list and a hash map, you should have a good understanding of when one might be the better choice than the other, and hopefully by the end of this video you will have a preference for whether Bank1 or Bank2 does a more efficient job storing a collection of bank accounts. So let's start implementing Bank1. So here I've created my shell for the Bank1 class. I'm going to fill in its single attribute, that private array list of bank accounts, named accounts. Now note that I do need to import the array list class to be able to work with it, so I will import it at the top here. And now that that's resolved, this just declares a space. It says, hey, I'm going to have an array list of bank accounts, but there is no memory allocated for this array list at this point. So at some point, we need to initialize or finish the line of code. I can do this in the same line, equals a new array list of bank account. This is more what we're used to when we work in a main method and we are actually creating an array list inside a main method. We typically do this all in one line. This is okay to do in a class, but when you have an attribute that is a collection type, or just an attribute that is a reference type in general, the more sophisticated way to initialize this would be to move this initialization into the constructor. So I'm going to take this, leave it as, hey, I've got a private variable, this is its type, it's called accounts, and when someone creates a new bank account, so I'm going to create my constructor here, public bank1, that's where I will initialize, hey, let's go grab some new memory, have my equal sign twice, but hey, let's go grab some new memory enough to store an array list of bank accounts. Just wanted to show you both ways. This is the preferred method of experienced programmers. Now that I have my field created and my constructor that initializes that one attribute, I'm going to create an accessor for this accounts attribute. Now, just like any other accessor, we're going to follow the typical conventions. I'm going to say it's public. It's going to return the same type that accounts is, so I'll just copy and paste that here. Returns an array list of bank accounts. And then to follow naming conventions, it's called get accounts. Just like this was any other variable, I'm going to just say return accounts. I could have also said return this dot accounts. That works the same way. But before we move on though, the interesting part about working with accessors like this is how to use and call them. So I do want to demonstrate that. I'm going to go to a tester class, and first I need to create an object of type bank1. So I'm going to create a bank1 object. I'll call it SunTrust. equals new bank1. You can clearly see here that this will call that default constructor, initializing that array list of bank accounts. If I wanted to get the array list out, now nothing else has been done, so there shouldn't be anything in it at this point, then I would say SunTrust.getAccounts, and you can actually see it populated here, .getAccounts. Because the getAccounts method returns an array list of type bank account, when this method is called, it's going to return the memory address where that array list is stored right here. So the common thing to do here is to have an array list of type bank account, a matching type, I can name it whatever I want, to catch it. Now, I don't like naming it something like B. I'm actually going to change the name to returned account. Okay, so again, when this method is called, it's going to go inside bank1. It's going to actually return accounts, which is just a reference. Think about wherever this array list is stored is a memory address. That memory address gets stored right here. And so returned accounts becomes an alias pointing to the same exact place in memory where all of my bank accounts are stored in an array list. So if I were to first just say system.out.println returned accounts.size, nothing has been done to populate that array list, so we would expect the size to be 0. But note that this is an array list of type bank account, so I can use all of the array list methods with it. I'm going to save and run it, and you can see the size of 0 printed here. All right, moving on, let's see what we need to code next. I would like to code this add account method. This method is public, it's void, and it's called add account. If we refer to the UML diagram, it said to accept a string owner and a double, I'm going to call it balance, as its parameters. And what we would like to do is if a bank calls this method, then what we would like to do is create a new bank account object with the owner and balance fields set to what was passed in. Then we would like to add that bank account to our collection. In this case, our collection is an array list. It's called account, so we're going to add it. Breaking these into two different steps. First, I will do this. I will create a new bank account object. Bank account. I can name it whatever I want. I'll name it B equals new bank account. Now, if I did not have the second constructor that exists in this class, then I would need to then say b.setOwner to the value of owner passed in, and b.setBalance, you can see these methods here, to the balance passed in. However, note that we had another constructor in here that accepted the owner and balance as parameters and initialized those. I would like to call that one to save time, so I'm just going to pass in my owner and balance here. Perfect. Now that I have that bank account object created, it's named B. I just want to add B to my collection, which is called accounts. So accounts.add B. Now, one thing that can be confusing is testing this out. The add account method exists inside the bank1 class, meaning that I need a bank1 object to call this method. One common mistake that I see is someone will come try to use accounts.addAccount and pass in a name like Barbara and $200. However, this is a mistake because accounts, first of all, is not a variable in this scope. It's a private variable declared over here, so I can't access accounts over here. So then they say, oh, well, I'll just use this alias for accounts. It's called returned accounts. But I want to stop and think about the type. This is a different kind of error. Returned accounts is type array list. There is not a method in the array list class called add account. And in fact, this add account method that I'm trying to call, I created inside this class named bank1. So any method listed in here, I have to call with an object of bank1 if that method is not static. If it's static, I can call using the name bank1. Perfect. So this add account method exists in Bank 1, so I need to call it with an object of type Bank 1, and I have that object here. It's called SunTrust. So basically, this is like having a certain bank add an account to their list. Note that if I had a second bank, I'm going to create another bank. This one's going to be called BB&T. Then BB&T would have its own list of bank accounts, right? So I have to specify which bank we're trying to add the account to. Perfect. So I'm going to comment this out because we're not going to use BB&T right now. But if I run this, it's not going to show me anything because there's nothing printed from this. This method doesn't return anything. What I can do though is I'm going to move the println statement below this add account method call so that hopefully I should have seen that the returned accounts, this array list, now has an increased size of 1. Again, this can be a little bit confusing because this account was not referenced here, but it is just an alias to that same spot in memory where accounts is stored. So I'm going to save and run this. And we should see that, yes, there is now one item inside the array list, whether we're calling it returned accounts or in this scope calling it accounts. Perfect, so we've done 2 out of our 3 methods. So now I will create my final method, which is called remove account. Public, it has no return statement, so void, it's named remove account. And it accepts an int, which is the account number, or I think I said ID in the UML diagram, but the account number of the bank account that you want to remove from the array list. It's actually pretty simple to remove from an array list. You just say the name of your array list dot remove, and you can see here that there are 2 different remove methods. One says to pass in the index of the element you want to remove, so remove element 0 or 1 or 2 in the list. The other one says to pass in something of type object. We haven't learned about this yet, so we're not going to try to use this second one. We're going to pass in the index that we want to remove. So I can pass in something like remove whatever's at index 0. This code is only going to remove the very first element in my array list. Unfortunately, that doesn't solve the problem of removing the element with the associated account number. If I wanted to remove someone with account number 1, 2, 3, 4, they might be the 5th element or the 10th element. I can't just put account number in here because again, they're probably not indexed at 1234. That's just the account number that is within that class. It might be stored at index 1 or 5. So what we have to do then is, in order to use this remove method, and I'm going to say that we do want to pass in the index, but we don't know what that is yet. I'll comment it out. We need to first find the index of the bank account with the given account number. The only way we're able to do that, there's unfortunately not a super quick method we can grab and use, is we're going to have to loop through our array list, looking for a matching account number. So let's first just focus on looping through our array list. There's 2 different ways to loop through an array list. We can use the normal for loop with indices, or we can use the enhanced for loop. Because we know we're going to have to do something with an index later on, I'm going to choose to use the normal for loop, where I have a int I equals 0, while I is less than the name of my array list, accounts.size, incrementing I each time. So this is guaranteed to grab each index of my accounts array list, no matter how many things are in there. And what I'm going to do is I'm going to get the bank account at that index. So accounts.get I for each time. Now this will actually return a single bank account because it stores bank accounts. So I'm then going to catch it or receive it over here with something of type bank account, and I'll just call it B. So in each iteration here, I'm going to grab the next bank account and just use the word B to refer to it. So then what I can do is when I've grabbed the first one, I can ask questions like if B's account number, let's use B.get account number. I can use any of the methods associated with my bank account class because B is type bank account. So B.get account number is equal to the account number that I'm looking for up here. Now I always double check when I compare two items that I am allowed to use equals equals or this comparison operator because these are both ints. This returns an int and we can see here that this is declared as an int. This is valid. I can leave this as using the comparison operator. But now going back to what I was doing, if B's account number is the account number we're looking for, then aha, the index that I'm trying to remove is this I that I was able to grab, right? So then if I find it, I'm going to then remove from accounts at that certain index. What this also means is that if for whatever reason you looped through this entire array list and never found a match, so this never evaluated to be true, then we would never remove anything, and I think that's okay too. All right, so now I'm going to save this and try to test it. I'm going to come up here, and in order to call the remove account method, again, I want to think about the class that it's in. It's right here in bank 1, so I need a bank 1 object to call it. I'll call it with SunTrust. I'm going to say SunTrust.removeAccount, and I'd like to remove somebody with the account 0. Now, in order to test this, I want to make sure that it's actually going to work. If I inspect my bank account class, I actually have num accounts starting at 1,000. We did this in that previous video. So the first bank account ever created, which is the bank account created right here by calling this method, creating the bank account, right here in this line of code, right? This is going to have an account number of 1,000. So when I test this, if I test it by trying to remove somebody with the account number of 0, it's not going to remove anyone because we don't have a bank account with the account number of 0. I can try it though, and we'll see that the returned account size should still be 1 because this should not have removed anything. I'm going to just run it. You can see that it still says 1, but if I pass in a valid account number here, again, when I created Barbara's account using this method, creating it inside here, it's the very first bank account that was created, so it should have received the account number of 1,000, and then we're immediately just removing her from the account. I'm going to save this and make sure it works. And it does. You can see that the account's size now went back down to 0. I'd now like to just look at a brief example internally of what's happening when I try to write methods like this. So here I have an example of just trying to create a bank account object. I've named it Joe's account, and hopefully we know by now that Joe's account is a reference type, so it actually stores an address. Joe's account is an alias for an address, which is somewhere in memory where enough space for an entire bank account exists. Bank accounts have those private fields, owner, balance, and account num. So you can see that Joe 200 and whatever his account number is stored in memory at this address that Joe's account points to. If I create another bank account object, like Mary's account, here you can see that it's a separate memory address. Just note the difference here between the two, but it also points to somewhere in memory where I have enough space for owner, balance, and an account number to be stored. With that in mind, when I created the array list to store bank accounts, what I'm really doing is I'm creating an array list that stores these memory addresses. So here I've got my array list that stores bank accounts. When I add Joe's account is again just the memory address for where his information is stored. So I'm adding this memory address to an array list. Same thing when I add Mary's account, I'm adding the memory address where Mary's account is stored to this array list. So this is what this looks like in memory. Accounts is a reference type itself, so accounts point somewhere in memory where I have an array list that stores each individual bank account address. The first one that's ever added is going to be at index 0. The next one is going to be at index 1, and so on. This can grow and shrink as needed. This is why in our remove method, what we had to do was loop through each index of the accounts list, right? Grabbing each bank account object out at a time and then looking at that address to see, let me go back here, to see at that address what their account number is and ask if it matched what we were looking for. So now I'm going to fill out my Bank 2 class, which instead of the array list of bank accounts, stores a hash map of bank accounts. So here I've got my one variable, a hash map that maps integers to bank accounts, and I've named it accounts. Now I do need to import the hash map class. I'm just going to change this to import the hash map class. And a lot of the things that we did are going to look very similar, but change slightly. So in this example, it's important to note that the integers that I want to map here are going to be the account numbers. So I'm going to just annotate that up top. Maps account num to bank account objects. So in our last example, we had the issue where when I wanted to search for a specific bank account by their account number, it required me looping through the entire array list, grabbing each account number out using the accessor method, and it just kind of took a lot of time. So what we're going to do here is when we put the bank account into the hash map, we're going to put the account number in also as a quick key to retrieve it. I want to first look at what this would look like in memory in comparison to our array list. So going back to these two bank account objects that I created in my last example, let's imagine we have them again. Joe's account just stores a place in memory where all of his account information is stored. Instead of just adding that bank account to my collection, I'm going to put the bank account and the account number as its key into my hash map. So I'm going to have a statement like whatever my hash map's name is, dot put Joe's account number, and then mapped to his actual address where his entire bank account is stored. So let's look at an example. So here I've created a hash map named accounts, and it maps those integers to bank accounts. So when I put something in accounts, I'm going to not just put in the bank account, which is what we did with array list. You can see here I'm putting in Joe's account, which just puts in the memory address. But I'm going to give it a key to retrieve it easier, which is the account number associated with it. I'm going to just use that same bank account object, .get account number, to get the account number out, and then feed it right back in to this as an argument. I'm going to do the same thing with Mary here. I'm going to not just put her address in where all of her information is stored, but I'm going to give it a key of her account number, which was 12346. Now let's take this idea and move this into our class. So to save time, I'm going to copy over some things from our Bank 1 class, but we're going to change them so that it works better with hash maps. So first, I'm going to just copy the constructor. I'll copy it over here. Note that this class is called Bank 2, so the constructor's name should also be called Bank 2. And when we initialize accounts, we're no longer initializing an array list, but we're initializing a hash map. So I'm going to put new hash map that maps not just bank accounts, but maps integers to bank accounts. Now that we've resolved that, I'm going to go back to my accessor method. The accessor method for this one was called getAccounts. It's going to be called getAccounts in the other one, but the only thing that will change is that we're no longer returning an array list of type bank accounts. We're going to return that hash map. So I can copy this over. But again, instead of returning an array list of bank accounts, I'll copy this. It's going to return a hash map mapping integers to bank accounts. Perfect. Now when I go back to Bank 1, there was the add account method and the remove account method. Just so that we can redo this work and really practice, I'm going to copy over the method headers, but I'm going to delete everything inside of them so that we can recode these ourselves. So with the add account method, someone was going to hand us the owner's name and the balance. We were going to create a new bank account and put that in our collection. So I'm going to, again, do the same code, bank account B equals new bank account. And then I'm going to put that bank account into our collection. Before I do that, I want to get the owner's name and balance into the bank account. We said we could either call the the mutator methods to mutate the owner's name and balance, or we could use that bank account's constructor that's already set up for us, passing in the owner and balance values here. I'm going to leave that like this, and then putting this bank account object named B into our accounts. In our last example, we just did this. We did accounts.addB. Note that there's not an add method with hash maps. It's called put. And we don't want to just put B in, this address, but we want to put its key in before it, the key being B's account number, b.get account num, and then map it to the actual account object. Now, because this is the very first bank account that should be created, it's going to have the account number of 1,000. And so this is going to grab 1,000 and map it to the address where this entire bank account is stored. Even though the actual name B will not persist beyond this scope, because we put the address into our hash map, this address can be brought back out at any time. If I compare this quickly to the add account method in Bank 1, just so I can see which way I prefer, Bank 1 looks a little bit more straightforward because this line of code is exactly the same, but I just get to add the bank account object. So it looks like it's more straightforward because I don't have another argument that I'm putting in to my collection. So maybe a tiny bit of upfront work here, but let's see if it's worth it when we try to then retrieve things from our collection. With a hash map, the remove method, accounts.remove, doesn't expect me to put the index in here, but it actually expects me to put the key. So it's as simple as saying remove the bank account object with this account number. Now, if we compare this line of code to this line of code, you can see that this method has a lot more upfront work because I have to loop through and find the right bank account before removing it by referring to its index, where over here, I've set up my own mapping system. And so when I want to retrieve something that has this given index, I just pass it in here. I shouldn't say index, this given key, I just pass the key in here. Note that this doesn't just work with the remove method, even though this correctly solves the problem. We can also use this with the get method, where I could get the bank account object with the associated account number. I could not do that with an array list because the get method expects you to put an index, not an account number in there. So even though it seems like it's a little bit more work up front to add these items or put these items into our hash map collections, when we're storing a collection of objects, because these are just memory addresses, it is really, really useful to map them to something more meaningful. Same thing at UGA, we use your 810 number or your MyID. We've got two different mapping systems where we map that unique value to your entire student account. We can test these methods in a very similar way. If I go to my tester code, instead of creating a bank 1, I need to create a bank 2 object. And then because bank 2 stores a collection of hash maps, I can't catch it here in an array list. I would have to catch it in a collection or a hash map that maps integers to bank accounts. So I'm just going to copy this over here. Catch this in this same exact type. You'll see that I copy and paste. This is just to remove the potential for errors. And then I can call the methods exactly the same. I can also have bank account 1 and bank 1 and bank 2 objects created in this same class, but I'm not going to demo that right now. I will just go through making sure that these work. We see 0 printed here, and if I just quickly revisit, I grabbed the hash map, stored it in something called returns accounts, added something or added a bank account to my hash map, but then removed it right back out. She had the account number of 1000, so this removed it. Now, just to make sure that this wasn't a fluke and it never added right the first time, I'm going to take out the line of code that removes it. I should then see that the returned account size be 1 because I added the account back in. I'm going to run it, and you can see this shows me that this did properly add the account, and thus having this line of code then removed that account back out. I hope this shows you the difference between using these two different collection types, and encourage you to practice with these and run many more test cases, letting me know if you have questions.